The universe should not exist. And I need you to understand that I am not being philosophical. I am not being dramatic for effect. That statement is the considered conclusion of some of the most brilliant physicists alive today, based on our best, most rigorously tested understanding of the fundamental laws of nature. The fact that anything exists at all, that there are atoms and stars and planets and you, is a mystery so profound that it threatens to undermine our entire framework of physics. Here is the problem, stated as simply as I can manage. When the Big Bang occurred 13.8 billion years ago, the laws of physics as we understand them dictate that it should have produced exactly equal amounts of matter and antimatter. Perfectly balanced, perfectly symmetrical. For every quark, an antiquark. For every electron, a positron. For every particle of matter that popped into existence, an identical particle of antimatter should have appeared alongside it. This is what the equations predict with crystal clarity. And here is the catch. When matter and antimatter meet, they annihilate each other completely and totally, converting 100% of their combined mass into pure energy in the form of photons. So if the Big Bang produced equal amounts of both, as physics says it should have, then every particle of matter should have found its antimatter twin within the first few seconds of the universe's existence. They should have destroyed each other entirely, perfectly, leaving behind nothing but a cosmos filled with radiation. A universe of light and nothing else. No atoms, no molecules, no stars, no planets, no oceans, no air, no life, no you, no anything. Just photons streaming through empty space forever. And yet, here we are, sitting on a planet made of matter, breathing air made of matter, made of atoms that should not exist. Somehow, for every billion pairs of matter and antimatter particles that annihilated each other in the first moments after the Big Bang, there was one extra particle of matter left over. One per billion. That staggeringly tiny, almost negligible imbalance, a surplus of just 1 part per billion on the matter side, is the sole reason that anything in the universe exists today. Every galaxy you have ever seen in a photograph, every star twinkling in the night sky, every atom in your body, every thought in your brain, all of it comes from that impossibly thin margin of survival. That 1 in a billion left over that somehow avoided annihilation. And the question that haunts physics is devastatingly simple. Why? Why was there one extra? Where did the asymmetry come from? This is called the baryon asymmetry problem, and it has been one of the deepest unsolved questions in physics for over 50 years. Our current best theory of particle physics, the Standard Model, which has successfully predicted the outcomes of thousands of experiments with extraordinary precision, cannot explain it. The Standard Model predicts near-perfect symmetry between matter and antimatter, with only the tiniest, most negligible asymmetry that is nowhere near large enough to account for all the matter we observe in the universe today. Something is fundamentally missing from our understanding. Something big. Some physicists believe the answer lies in a phenomenon called CP violation, where certain particle interactions show a measurable, but very slight, preference for matter over antimatter. We have detected and confirmed CP violation in particle accelerator experiments. It is real. But the amount of CP violation we have measured so far is orders of magnitude too small to explain the cosmic imbalance. It is like finding a single drop of water and trying to use it to explain the Pacific Ocean. Others believe there might be undiscovered particles or entirely unknown forces that tipped the cosmic scales decisively in favor of matter during the first trillionth of a second after the Big Bang. Experiments at CERN, Fermilab, and particle physics laboratories around the world are actively, urgently searching for evidence of these hypothetical particles and forces. So far, despite decades of searching, they have found nothing definitive. Then there is an even wilder, more exotic possibility that some cosmologists have proposed. What if antimatter did not actually disappear? What if it still exists, in vast quantities, in regions of the universe so distant and so isolated from us that we have never detected it? There could be entire antimatter galaxies out there, billions of light years away, made of anti-stars, orbited by anti-planets, possibly even populated by anti-life. We would have almost no way of detecting them from a distance, because antimatter emits exactly the same light as regular matter. An antimatter star looks identical to a matter star. Only at the boundary, where matter and antimatter regions might meet and annihilate, would we see any evidence. And we have not found such boundaries. Yet. But here is what truly keeps physicists awake at 3 in the morning, staring at the ceiling. The conditions required for the matter-antimatter asymmetry are so specific, so precisely and delicately tuned, that even the slightest change in any of dozens of fundamental parameters would have resulted in a universe with no matter at all. The strength of the strong nuclear force, the masses of quarks, the rate of cosmic expansion, the energy density of the early universe. Change any of these by even a tiny fraction of a percent, and matter loses its slim advantage. Antimatter wins the war of annihilation. And the universe becomes nothing but an eternal, empty bath of cooling radiation. You are not supposed to be here. I am not supposed to be here. None of this, not a single atom of it, is supposed to be here. And the fact that it is, that against all mathematical odds and physical predictions, a universe full of stars and life and consciousness emerged from that impossibly thin margin, that might be the single greatest mystery humanity will ever face. If you want to keep questioning the deepest nature of reality with me, hit that subscribe button. Because the deeper we dig into this,